Today is 13th of March in the year 2020. It is also a Friday. Now, some believe that Friday the 13th is an unlucky day. In fact, the number 13 in the Western civilization, in the Western culture, is an unlucky number. Some of the buildings, they skip 413 altogether. As you can see from the lift buttons here, there is no number 13. So from 12.4, they jump straightly to 14.4. Some would insert a funny number between 12 and 14, like this one. You notice an interesting 412A. 12A was in fact 13.4, but they would rather not put the number 13 there and replace it with 12A. Now, there's a similar thing in the Chinese culture. In Cantonese, I don't know whether about the northern China, but in Cantonese, we believe the number 14 is a superstitious number. So you see in Wang Shetbao, in Windsor's house, they're supposed to put a 14th floor, but it's supposed to be a restaurant. But they don't like the number 14, so they replace the 4 number with 15A to skip that, unlucky number. Alright, so much about superstition. But we want to ask one question because Friday the 13th is supposed to be an unlucky day. But how likely is the Friday on the 13th? How likely is Friday the 13th? Alright. So there are several ways to answer this question. Alright, say, the first one, she argues that, for every Friday, alright, the Friday can be on the 1st of March, the 2nd of March, and so on. Alright, all the way, say, the 30th of March. Alright, suppose on average, each month has 30 days. Alright, so for every Friday, it can be the 1st, it can be the 2nd, and so on. So for the Friday to be the 13th, the chance is 1 over 30. Alright, because every Friday, it can be the 1st of the month, the 2nd of the month, and so on. So she says that Friday the 13th, the probability is 1 over 30. Well, there's another one. She has a different idea. Because every month there is a 13th of January, 13th of February, for example. Every 13th, it can be a Monday, it can be a Tuesday, alright, and so on, all the way until the 13th can be a Sunday. In order to have the Friday the 13th has to be on a Friday. So there is a 1 over 7 chance to be the Friday the 13th. Right, because every 13th, it can be a Monday, Tuesday, and so on. Suppose it is random, then there is a 1 over 7 chance to be Friday the 13th. So that's the second answer. But then a third one comes along and say, hey, Friday the 13th, it must be both Friday and 13th, right? Friday the 13th, so the chance will be, it must be a Friday, so it's 1 over 30. It must be a 13th, so it's 1 over 7. So the chance of Friday the 13th will be 1 over 210. Alright. So now we have 3 versions. We have the blue version. The chance of Friday the 13th is 1 over 30. The orange version. The chance of Friday the 13th is 1 over 7. Or the third version. The chance of Friday the 13th is 1 over 20. So, who is correct? Who is wrong? The question is, how likely is Friday the 13th, right? So what's the answer? The answer is that all 3 of them, the blue one, the orange one, the purple one, they can be right, they can be wrong, because the question is ill-defined. It is not a very good question. Alright. Now let me see. What do this blue, orange, purple number means? What does this blue number means? This blue number actually means Friday the 13th, given it is a Friday. Alright, remember conditional probability. If it is a Friday, then the probability of Friday the 13th will be 1 over 30. So now you know the orange number that today is Friday the 13th, given it is the 13th. Right. If it is the 13th today, then the probability that it is Friday the 13th will be 1 over 7. Alright, so the blue one, the orange one, they are both correct because they are talking about different things. They are talking about different conditional probability. So what does the purple one means? The purple one means you pick a random day, all right? You just wake up and say, oh, what is the probability that today is Friday the 13th, all right? Or you pick a calendar and you just pick a random day from the calendar. That random day is Friday the 13th. The probability is about 1/210, all right? I said about because not every month got 30 days, all right? It's roughly an approximation, all right? So this is a poor question to ask. How likely is Friday the 13th? It is an ill-defined question. The better question is, all right, if you want to look at the frequency, all right, whether Friday the 13th is a common occurrence or is it a rare occurrence, the better question to ask, in fact, is what is the expected number of Friday the 13th in a year? What is the expected value? What is the expected number of Friday the 13th in a year, for example? Or you can ask, what is the expected number of Friday the 13th in a decade? All right, you just multiply it by 10. All right, so that is the better question to ask. All right, in 1 year, how many Friday the 13th do you expect in 1 year? Right. So the better question to ask is not the probability question, but its sister question, the expected value question. All right. So we can start from the purple one because any random day, the probability for the Friday the 13th is 1/210. All right, and we have 365 days roughly, right, every year. So the expected number of Friday the 13th every year is about 1.73. All right, there are so many, roughly 1.7, right? So every year you expect to see, well, maybe at least one Friday the 13th, all right? Sometimes it can be 2, all right? It's more likely that 2 than 1 because 1.74 is close to 2, all right? But sometimes there are years that has 3 Friday the 13th, all right? Now, I leave a link in the comments, comments below for more information on Friday the 13th. So it's not rare, I have to say. Every year you have to expect 1 to 2 Friday the 13th. All right. So probability is not just about a calculation, but you have to ask the right question to get the meaningful answer.